back to this session. So as you can see that for the past few days we have been solving shear force and bending moment diagram for three different types of beams, that is simply supported, cantilever and overhanging beam. Now here, as you can see in this diagram, this is a cantilever beam, and I'm considering this into some typical kind of questions. Okay, so now as you can see in this diagram, it is a normal diagram, but at the end, at point B, you can see that a load is acting of 15 kilonewton per meter. Now this 15 kilonewton per meter is a moment. When this kind of load acts on any beam, it is known as a couple. Let us start by finding its reactions. Number one, reaction. Now for this case, this is a cantilever beam, and for cantilever beam there is only one reaction, and the reaction will come at this fixed end. So I have RA equals to total load on the beam is 30 plus 20, which is equals to 50 kilonewton. Now let's find shear force calculation. Shear force will be equal to, force at A will be equal to RA, which is 50 kilonewton. Now force at C, left hand side of C, will be equal to, last force that I got is 50 kilonewton, and there is no force in between A and C, so it will remain 50 only. Right? Force at C, right hand side of C. Right hand side of C is this direction, so it will become equal to 50 minus, there is 30 kilonewton load acting on top of C, so minus 30, which is equals to 20 kilonewton. Okay, now from here, force at B will be equal to, the last force that I got is 20, and is there any force in between C and B? There is no force in between C and B, so it will remain 20 kilonewton, which is exactly the force that is acting at point B. So our calculation here is right. Now let's draw the shear force diagram first. At A I have 50 kilonewton, right? So this is 50 kilonewton, and this is going constant till C point, and at C point, when it is going to the right hand side direction, it is reducing and becoming 20 kilonewton here. So it has reduced 20 kilonewton here, and it is going constant till B. B तक ये constant है 20, so यहाँ पर भी 20, so join the line. So the whole of this is 20 kilonewton. This is positive, let's shade it. A, C and B point. This is my shear force diagram. Now let's find moment, bending moment. For a bending moment calculation in a cantilever beam, as you know that ये free support पे, free end पे, जहाँ पर support नहीं है, free end पे moment नहीं आते हैं, moment will be equal to 0. But right now in this case B point पे एक moment, there is already one moment acting, and the intensity of this moment is 15 kilonewton meter. So moment at B is equal to 15 kilonewton meter, and since it is going in a clockwise direction, cantilever पे clockwise is negative, so minus 15 kilonewton meter. Now let's find moment at this point, C point. So moment at C will be equal to, now I have to come from B to C. So there is this couple acting and then this point load which will also go in a clockwise direction. So couple's direction is clockwise, so minus 15. Since ये couple का unit is already in kilonewton meter, already a kilonewton meter है which is already a moment, तो हमें we don't need to multiply it again with a distance. Okay, so ये इतना ही रहेंगे, we don't need to multiply it with the distance. Then I have a 20 kilonewton load, so it is going in a clockwise direction, so minus 20 into, now what is the distance from B to C? It is 1 meter, so into 1. This will be coming equal to minus 35 kilonewton meter. Okay, now let's find moment at A point, which is a fixed end point. So there I have to come from all the way from B to A, right? So what are the forces and couples acting? One couple at B and then 20 kilonewton load, and then this 30 kilonewton load which will also be going in a clockwise direction towards A, right? So this will be coming equal to minus 15, then minus point load 20 into the distance will change now. B से A तक distance कितना है? 1 plus 1 2 minus point load 30 kilonewton point load, so 30 into distance from C to A is 1 meter into 1. So this will be giving you value equal to 85 kilonewton meter. So now let's draw the shear force bending moment diagram. So at point B, this time it is not 0, it is minus 15. So minus 15. Here I have 15 kilonewton meter. C point I have minus 35. So minus 35 here, 35 kilonewton meter, and at A I have 85 kilonewton minus 85 kilonewton meter. Now let's join the lines. So from here it will be going this way and then in this manner. So this is negative, this is the bending moment diagram. So I hope this numerical is clear. Let's solve the second numerical for today's session. So again, in here a cantilever beam is given. So at the end B there is a couple. Okay, couple of 1 kilonewton meter is acting. So let us see how we can find shear force and bending moment for such cases. Let us solve this numerical by finding its reaction first. Since this is also a cantilever beam, I'll have reaction only at this point A, and let me name this at B. So I have RA equals to 3 into 2, which is equal to 6 kilonewton. Now let's find shear force. Number 2, shear force calculation. Okay, for shear force I have force at A will be equal to RA, which is 6 kilonewton. Since RA is going from bottom to top, so it will be positive, and I have a UDL acting, so minus, since UDL is coming from top to bottom, so it will be minus 3 into A point पे UDL शुरू ही हुआ है तो it will be 0, right? So this will be coming equal to 6 kilonewton only. Now let us find force at B and left hand side of B का left hand side. So last force that I got is 6 minus, now A से लेकर B तक UDL चला है, 2 meter distance तक UDL चला है, so it will be 3 into 2. This will give exactly 0. Now I don't have any moment, any force acting at this point B, so it is exactly 0 here, and we got 0 in our calculation also. Now let's draw the shear force diagram. Here at point A I have 6 kilonewton and at point B 0. So drawing the line, it is positive. This here is 6 kilonewton. Let's shade it. This is shear force diagram. Now let's find moment. So bending moment calculation. Okay. So in bending moment calculation, for a cantilever beam at a free end, the moment should be equal to 0. But as you can see at this point here right now, ये point पे एक couple is acting. So this couple is already a moment. So moment at B, there is already a couple acting, and it is a moment. So this will come, and the direction of this couple is going in a anti-clockwise direction. So anti-clockwise in a cantilever beam is positive. So I have plus 1 kilonewton meter moment acting at B point. Now I want to find moment at this point A, which is my fixant. So moment at A will be equal to, now I have to come all the way from B से लेकर A तक आना पड़ेगा. So what are the forces? One is already a moment, 1 kilonewton meter moment. Then another is this UDL. अब जब ये UDL A की तरफ जाएंगे, so the direction will be in this direction, which is a clockwise direction. So let's see how we can find. First I have a couple going in a anti-clockwise direction, so plus 1. Then I have a UDL going in a anti-clockwise, first I have a couple going in the anti-clockwise direction, which is plus, and then I have a UDL going in a clockwise direction, which is minus 3 into the distance of this UDL is 2 meter into, and it will act at a distance of half the distance. So this will be giving you 1 minus 6 will be equal to minus 5 kilonewton meter. So this is the moment. Now let's draw. So now at B point I have plus 1 kilonewton moment. So here plus 1 kilonewton meter, and then at moment at A I have minus 5. So 5 kilonewton meter. Let's join. It will join in this manner. Now this line which is going in this manner, this is also known as a second degree curve. Why is it known as second degree curve? Because it is going from this negative here, and then it is directly going to a positive. So it will go all in a curvy manner, and since the load, kind of load that is acting here is a UDL, so UDL के लिए parabola आएंगे, And again, because since it is going from negative to positive directly, so this kind of curve is known as the second degree curve, and this is the bending moment diagram. So I hope this numerical is clear. This is the last numerical for today's session, and this is also the last numerical for this unit, which is unit number 4, shear force and bending moment. And now let us see how we can find shear force and bending moment diagram for this cantilever beam with a couple. Okay, so let's get started. Let us start by finding its reaction. So here also I'll have only one reaction since this is a cantilever. So it will be RA at fixed end. So it will be equal to total load on the beam, which is 40 into 2. That's it. There is no other load. So this will become equal to 80 kilonewton. Then next, let's find shear force. Shear force calculation. Now, force at A will be equal to RA, which is equal to 80 kilonewton. And it is positive because RA is going from bottom to top. Okay. Next, let's find force at B and left hand side of B. Last force that I got is 80 kilonewton. Is there any force acting in between A and B? There is no other force, so it will be 80 kilonewton only. Now force at B, right hand side of B. Now when it is going to the right hand side, it will go this direction. So last force that I got is 80. Now a UDL is acting, so UDL minus 40, and the distance, it has just started at this point B, so its distance will be 0. So again we have 80 kilonewton load. Now force at C and left hand side of C. Force at C and this side of C, I have last force I got 80 minus, now ये force जो UDL B से start हुआ है, it has traveled a distance of 2 meter and reached point C. So I have a UDL and it has traveled, by the time it has reached C, it has traveled a distance of 2 meter. 2. So 80 minus 80, 0. So I have at C point I have 0 force. Okay, kilonewton. Now since I have 0 here till D, there is no other force, so there will be no other force. It has stopped here. Okay, now let us draw the diagram. Force at A 80, right, and then till B it is constant again, 80, right, and C point पे it is becoming 0. So here I have 80 kilonewton, and suddenly when it is reaching C point, it is becoming 0, right? So this is a positive, this is the shear force diagram. Now let's find bending moment. Okay. So in here also we have a couple acting at the free end, but अगर free end पे ये couple नहीं होता तो moment at D will be equal to 0, but यहाँ पर अभी couple act हो रहा है तो moment at D will be equal to this couple, and the direction of this couple is a anti-clockwise, or anti-clockwise in cantilever is positive. So 80 kilonewton meter. This is not by meter, it is 80 kilonewton meter. Okay, and next let us find moment at this point C. Moment at C will be equal to, again it will remain constant. Okay, we have couple acting, in between there are no other forces, so this couple will be coming as 80 kilonewton meter. Now moment at B will be equal to 80 kilonewton. Now this UDL will be acting in a clockwise direction when it is going towards B. So I have clockwise is minus 40 into the distance of this is 2 meter into 2 by 2, right? So 2 gets cancelled, so I have 0 kilonewton meter moment at B point, so it is 0. Now moment at A point, moment at A will be equal to 80 minus the UDL, which is 40 into 2 into 2 by 2. now UDL सिर्फ 2 मीटर डिस्टेंस पे एक्ट हो रहा है, बट हम अभी मोमेंट एट ए पे फाइंड कर रहे हैं, तो रिमेनिंग डिस्टेंस यहाँ से यहाँ तक का डिस्टेंस हमें लेके जाना पड़ेगा. तो व्हाट इज द रिमेनिंग डिस्टेंस? इट इज 2 मीटर. सो प्लस 2. सो दिस विल बी गिविंग यू 1 plus 2 3 into 2 6 into 40 will be equal to 240. So 80 minus 240 will be equal to, it will be equal to 160 minus 160 kilonewton meter. Okay, now with this let's draw the diagram, bending moment diagram. Okay, so moment at D पे 80 है, right? और ये C तक कांस्टेंट चल रहा है 80, C पे भी 80 है, and then at B point it is becoming 0 0, and at A point we have minus 160. So this will go in this manner. So here this should be a curve, this is a curve, and here this is also a curve. Okay, this is negative here and this is positive, and this one here is 160 kilonewton meter. Okay. And here is 80 kilonewton meter. This is a bending moment diagram. So I hope this numerical is clear. This is the last numerical for this unit. From next session we will be starting a new unit. So see you in next session.